Consider a polynomial like p of x equals to 4x raised to 4 plus 5x cube plus 6x square plus 7x plus 5. In this polynomial, the 4 is called coefficient of x raised to 4 and 5 is called coefficient of x raised to 3 and 6 is called coefficient of x raised to 2 and 7 is a coefficient of x and 5 is called constant. The largest power to x, power or index, some people call power and some people call index and some people else also call exponent. So the power of x is 4 here, largest power is 4. So this is called polynomial of degree 4. Polynomial of degree 4. Suppose I am having p of x is equal to x raised to 6 plus x square plus 3x plus 5. So it is a largest power to the x is 6. So it is a polynomial of degree 6. Definition of degree of polynomial. Degree of polynomial is the largest power. Here was the x and the largest power was 4 here. So degree of polynomial was 4. X is called variable. So degree of polynomial is the largest power given to x, that is it is the greatest exponent. Exponent means power, index. So it is the greatest exponent of any expression in the given polynomial. So this is a given polynomial. In this given polynomial, the greatest power is 4. Therefore, we call it as a degree of polynomial is 4. So it is a fourth order degree polynomial. In case of partial fraction, we must know two types of the fractions. One is a proper fractions and the another one is a improper fractions. So now I am going to talk about proper fractions and improper fractions, and let us understand them by taking one example. As I told you, the fractions are two types, proper fraction and improper fraction. To understand that, let us consider one algebraic fraction in terms of p of x upon q of x. So let us call it as a p of x and upon q of x. Here in the example number 1, I am having p of x equals to x square plus 5x plus 6. This is numerator, and x cube plus 2x square plus 4x plus 6, it is a denominator. So the degree of, here is a degree of numerator is smaller than degree of denominator. This type of fraction is called proper fraction. Now under the improper fraction, here again p of x upon q of x. Here is a degree 4 and here is a degree 3. That means degree of p of x larger than degree of q of x, then it is called improper fraction. Or degree of p of x equals to degree of q of x, then also it is called improper fraction. Thus fractions are two types, proper fraction and improper fractions. Now I got one example for you. In this example, I got a single fraction, 2x plus 1 upon x plus 1, x plus 2 and x plus 3. This single fraction is written addition of three different fractions. This is the first fraction, this is second fraction, and this is a third fraction. If I add all the three fractions, then I am going to get the original one. So a big one is converted into smaller parts. A big fraction got converted into sum of the three fractions. Now all the three fractions together called partial fractions. And in today's class, I am going to explain you how to convert the given single one into partial fractions by using different methods. I want to tell you one thing clearly, that if the given fraction is a proper fraction, then only you convert into partial fractions. If it is an improper one, then first convert into proper one, then you perform the procedure of partial fractions. Now I am going to explain you the first method. In the first method, I am having 2x plus 1 upon x plus 2 and x plus 3. Now, first of all, we must observe that, is it a proper fraction? Answer is yes, it is a proper fraction. Second question, you have to answer yourself that is it already in the factorization form? Yes, already the denominator already got factorized. No further factorization is required. The third question you have to ask yourself, that in the denominator inside the bracket, the x is single like a number. Here is a number 1. Here is a number 1. If there is no 1, suppose there is a 2, then you cannot procedure method number 1. You require to go for the method number 2. So in the method number 1, here are the no number, like here x square. If it is x square, there you cannot perform the method number 1. In the denominator, the monomials are there. That means the x raised to 1, degree 1 functions are there in each bracket. So now you go for making the partial fraction for that. So but we don't know the exact what is the numerator of each partial fraction. So we call it as a upon x plus 2 and b upon x plus 3. So the given fraction got converted into now partial fraction. Now it is our responsibility to find the value of a and to find the value of b. How to find out value of a and b, I will tell you little after by taking some examples. But now just I am telling you the procedure, how to get converted the single fraction into partial fraction. In the denominator, x only x terms are there, x square, x cube, x4 are not there. So this is the first method. This is the method 1. Now I go for the method number 2. In the method number 2, 2x plus 1 is there, but in the denominator x square plus 2 is there, and here is a x plus 3 there. Then how are you going to perform the partial fraction? If it is square term is there in one of the bracket, then the partial fraction can be written in the form of ax plus b upon x square plus 2 and c upon x plus 3. So the partial fraction for single x raised to 1 and partial fraction for x raised to 2 are different. A different procedure is there. So this is called method number 2. Method 2. I repeat once again. If in one of the bracket square term is there, then you write down ax plus b and plus c. Now it is your responsibility to get the value of a, b, c. Now under the next method, method number 3, suppose 2x plus 1 upon x plus 2 whole cube x plus 4 square is there. How will you write partial fraction? Partial fraction can be written this way, a upon, and here is a cube is there. So you start with the power 1, x plus 2 raised to power 1, and b upon x plus 2 whole square till you get the cube. Keep on writing x plus 2 whole cube. And now second bracket x plus 4 whole square. For that, d upon same procedure, x plus 4 plus e upon x plus 4 whole square. This way we write the partial fraction if outside the bracket having some index. Now next example, that is a method number 4. Under this method 4, some power is there inside as well as the outside. How to write that? I will write one example and show you. In the next method, I got here 2x plus 1 upon, suppose here is a x square plus 1, and outside also there is a some number like square, and here is a x square plus 5, and here is a some cube is there. So how you are going to write the partial fraction for this? So same procedure here, but the extra alphabets will come. Ax plus b will come. Why? Because inside the square is there. So I got here the x square plus 1, and here is a cx plus d. The same procedure as shown in the method 3 will be followed, but because square term is inside as well as, therefore I am going to write here combination of the method 2 and method 3. So x square plus 1 and till square I get here, I keep on writing. Now for the second bracket the same, we repeat till we get the power 3. That is a ex plus f upon x square plus 5. Then gx plus h upon x square plus 5 whole square till cube I keep on writing. Then jx plus k upon x square plus 5 whole cube. You can take any alphabets in the numerator, like here I have taken a, b, c, d. You can take anything whatever you desire, but they are constant. We need to find the values of a, b, c, d, and how to find the value of a, b, c, d by some procedure, that is our responsibility. Now these are the 4 methods. Now let us solve some examples on the basis of above 4 methods. Before proceeding further, I want to repeat here. Now in the first bracket we got here x plus 1, and in the second bracket I got x square plus 4. The first bracket is nothing but having linear factor, and the second bracket having quadratic factor. For linear factor, we simply write a upon x plus 1, and for quadratic factor we write two constant, that is the b and c. Bx plus c will come upon quadratic factor. And suppose x plus 5 upon x plus 1, x square plus 4 whole square. So quadratic factor also having some index, some exponent. In that case, how to write the partial fraction? That is a upon, here is a linear factor, so we just write a upon x plus 1, but the second one is a quadratic factor as well as having index 2. So x square plus 4 whole square. So what I do here, first I write bx plus c upon x square plus 4, and after that, because the power 2 is there, so I need to get one more fraction, dx plus e upon x square plus 4 whole square. This way we develop the partial fractions. Now I am going to solve some examples for you for better understanding. Resolve into partial fractions x upon x plus 1, x plus 2. We observe that in denominator both the factors are linear factors. Therefore, x upon x plus 1, x plus 2 can be resolved into partial fraction by method 1, that is a upon x plus 1 plus b upon x plus 2. Now we have to find out the value of a and b. For that, LHS as it is, in RHS, a into x plus 2 cross multiplication, b into x plus 1 upon x plus 1 into x plus 2. Both side denominators are same. Cancel them. I get x equals to a into x plus 2 plus b into x plus 1. Now we have to find the value of a and b. To find the value of a and b, we have to make one of the bracket equals to 0. For example, here is the first bracket. I want to make it 0. So x plus 2 equals to 0. Therefore, x equals to minus 2. That means in this equation number 1, if I put x equals to minus 2, then I will get the value of b. That is minus 2 equals to a into minus 2 plus 2 plus b minus 2 plus 1. Minus 2 equals to a into 0 plus b into minus 1 implies minus b equals to minus 2. Therefore, b equals to 2. Now we need to get the value of a. To get the value of a, I need to make the second bracket equals to 0. That is x plus 1 equals to 0. Therefore, x equals to minus 1. Now put x equals to minus 1 in the equation 1. So minus 1 equals to a into minus 1 plus 2 plus b minus 1 plus 1 minus 1 a into 1 plus b and 0. Therefore, minus 1 equals to a implies a equals to minus 1. Now we got the values of a, and a value how much? A value equals to minus 1. And we got b value. What is the b value? B value equals to 2. Once we get the value of a, in place of a, I will put the value of minus 1. And in the place of b, I can put the value of 2. Once I get the values of a and b, I can put here. So x upon x plus 1, x plus 2 equals to minus 1 upon x plus 1 plus 2 upon x plus 2. So this is first fraction and this is the second fraction. Both together required partial fraction. Now let us solve one more example. Example 2, resolve into partial fractions. 9x upon x plus 2 whole square. Solution. Here the basic step are as it is, but in the denominator square is there. Therefore, partial fractions will become a upon x plus 2 plus b upon x plus 2 whole square. Therefore, it becomes a into x plus 2 plus b upon x plus 2 whole square, and LHS is 9x upon x plus 2 whole square. Both side denominator get cancelled. We get 9x equals to a into x plus 2 plus b. Now we need to find the value of a and b. So let us call it as a equation 1. To find the value of a and b, what I need to do, I make this bracket equals to 0. That is x plus 2 equals to 0. Therefore, x equals to minus 2. Therefore, equation 1, 9x equals to a into x plus 2 plus b. Put x equals to minus 2 in equation 1. So 9 into minus 2, a into minus 2 plus b, minus 18 equals to a into 0 plus b, implies b equals to minus 18. To find the value of a, what we'll do? We'll put x equals to 0 in the equation 1. Put x equals to 0 in equation 1. So 9 into 0, a into 0 plus 2 plus b. 0 equals to 2a plus b. We are already having b value, minus 18 equals to 0. Therefore, 2a equals to 18, a equals to 18 upon 2, therefore a equals to 9. So we are having both the values here, a value and the b value. So what we'll do now? We'll put a equals to 9 and b equals to minus 18. Therefore 9x upon x plus 2 whole square equals to 9 upon x plus 2, and b value minus 18 upon x plus 2 whole square. So 9 upon x plus 2 is the first partial fraction, and these are the required partial fraction. Let us move to the next example. Next question, example 5. Resolve into partial fractions 2x plus 1 upon x minus 2, x square plus 1. We observe that here is a linear factor and here is a quadratic factors. Therefore, 2x plus 1 upon x minus 2, x square plus 1 equals to a upon x minus 2 plus bx plus c upon x square plus 1, which is equals to a into x square plus 1 plus bx plus c into x minus 2 upon x minus 2 x square plus 1, and LHS was 2x plus 1 upon x minus 2 and x square plus 1. Both side denominators are equal, therefore they get cancelled. Now what are left? Numerator 2x plus 1 equals to a into x square plus 1 plus bx plus c into x minus 2. Now we can find out the values of ABC in various methods. The very simple method is putting x value both sides to make one of the terms 0. Put x equals to 2, therefore this much part becomes 0 and we easily get the value of a. So here is a 5, here is a and here is a 5, and this part becomes 0, implies a equals to 1. Now we have to get the value of b and c. To find out the value of b and c, I put x equals to 0. Putting x equals to 0 is equivalent to comparing both side constant terms. So put x equals to 0. So 0 plus 1 equals to a into 0 plus 1 plus 0 plus c and 0 minus 2. So a minus 2c equals to 1, and we are already having a value. Put here a value. So minus 2c equals to 1 minus 1 minus 2c equals to 0. Therefore c equals to 0 value. Till now we have the values of a and c, but we don't have the value of b. To get the value of b, we will select x equals to some other value which is already not selected, but try to be, it should be a small number. So we had selected x equals to 2, we had selected x equals to 0. Now another small number which not makes any term 0, and so that is equals to 1. So I select a small number which makes nothing 0, and we need to get the value of b now. So a value is already there and c value already there. We need to require the value of b. For that I am going to put x equals to 1. Now, so 2 into 1 plus 1, what is a value? Where a value is already 1. So putting the a value here. So 1, x value is 1, 1 square plus 1 plus b into 1 plus c value 0, x minus 2, 1 minus 2. So we got here 2 plus 1 equals to 1, 1 plus 1 plus b and multiplied by minus 1. So we get here minus b equals to 3 minus 2 implies b equals to minus 1. Thus we got all the values of a, b and c. So what we do now? We put back to the equation. Where is the equation? Here. What was the a value? A value equals to 1. And what was the b value? The b value equals to minus 1 here. So I am going to put the b equals to minus 1 and c equals to 0. So we get the partial fraction of given question. Therefore 2x plus 1 upon x minus 2 into x square plus 1 equals to a, that is 1 upon x minus 2 plus b, that is minus 1 x plus 0 upon x square plus 1 equals to 1 upon x minus 2 minus x upon x square plus 1. So this is the first fraction and this is the second fraction. Both together are partial fractions of what? Of given question. This was the given question. Therefore, these are the two fractions, nothing but required result or required answer. Next example, resolve into partial fractions 3x plus 1 upon x square into x plus 1. 3x plus 1 upon x square into x plus 1, which can be written as 3x plus 1. My habit to write down linear factor first. After that, I do write the quadratic factors. And now partial fractions of this can be written as a upon x plus 1 plus b upon x and c upon x square. This can be written as a. First of all, write down x plus 1 and x square, and ask yourself, here is a x plus 1 is there. What is not there? X square is not there. So create x square. We call it as a method of equalizing the denominators. Now b upon x is there, x square is not there. So multiply, divide by x, and x plus 1 is also not there. So multiply, divide by x plus 1. This procedure is called equalization of denominator. See, x square is there, but x plus 1 is not there. So multiplying and dividing by x plus 1, which gets converted into the ax square upon x plus 1 into x square plus bx into x plus 1 upon x plus 1 into x square plus c into x plus 1 upon x plus 1 into x square. Now next step, 3x plus 1, LHS as it is, but RHS, all the denominators are equal. Therefore, we can write it ax square plus bx into x plus 1 plus c into x plus 1 upon x square into x plus 1. All the denominators are equal. Therefore, I can add the all numerators. Now, in LHS and RHS, denominator are equal. So, cancelling them. And after that, writing three x plus 1 equals to a into x square plus bx into x plus 1 plus c into x plus 1. If you are watching this video, if you like my presentation, I request you to subscribe the channel and tell your friends, so that my channel will grow and I will get motivated to develop better quality videos. Now next step, we have to find a equals to how much, b equals to, and c. So we need to find the a, b, c values. For that, we put x equals to minus 1, x equals to 0, and x equals to 1. I told you already the idea. First of all, I make the two terms 0, and now third term x equals to 1, so that no terms become 0, and easily I will get the values of ABC. Now to find the values of ABC are left to you. I will write directly the calculated values of ABC. Then we get a value, a equals to minus 2, and b equals to 2, and c equals to 1. Therefore, required partial fractions are minus 2 upon x plus 1, and the b value 2, 2 upon x, and the c value is 1, so 1 upon x square. So these are required partial fractions of this question. So partial fraction of 3x plus 1 upon x plus 1 into x square are minus 2 upon x plus 1 plus 2 upon x plus 1 upon x square. Example 7. Resolve into partial fraction 1 upon 1 plus x cube. Now there are no factors, neither the linear factor, nothing else. So how to resolve into partial fraction? For that, first of all, we think what type of fractions are possible. 1 can be written as a 1 cube and it is x cube. So here is a formula, a cube plus b cube can be applied, that is equals to a plus b into a square minus ab plus b square. Therefore 1 upon 1 plus x cube can be written as 1 upon a plus b, that is 1 plus x and a square minus ab plus b square. Therefore given problem is equivalent to 1 upon 1 plus x, 1 minus x plus x square. Now this problem can be resolved. Here are the linear factor and here are the quadratic factor. For linear factor we can write a upon 1 plus x, and for the quadratic factor we can write bx plus c upon 1 minus x plus x square. Therefore 1 upon 1 plus x cube equals to 1 plus x 1 minus x plus x square equals to a into 1 minus x plus x square plus bx plus c into 1 plus x upon 1 plus x 1 minus x plus x square. Both side denominators are equal, get cancelled. So we get 1 equals to a into 1 minus x plus x square plus bx plus c into 1 plus x. Call it equation 1. Now put x equals to minus 1. So I get here 1 equals to a into 1 minus into minus plus 1 plus b minus 1 plus c. Here is 1 minus 1. So we get 3a equals to 1, implies a equals to 1 upon 3. If I put x equals to 0, then a into 1 minus 0 plus 0, 0 plus c, 1 plus 0. So 1 equals to a plus c. But already a value 1 by 3. Therefore 1 upon 3 plus c. Putting the value of a equals to 1 by 3. So we get c equals to 1 minus 1 upon 3 equals to 2 by 3. Therefore c equals to 2 by 3. Now left with the b value. For that we select x value such that none of the bracket becomes 0. That usually I follow when the 3 coefficients are there. Now I put x equals to 1 such that no bracket becomes 0. So in equation 1 I am putting x equals to 1. So a 1 minus 1 plus 1 square plus b plus c and 1 plus 1. So 1 equals to a plus b plus c into 2. 1 minus a equals to b plus c into 2. What is a value? A value 1 by 3. So 1 minus 1 upon 3 equals to b plus c 2. So 3 minus 1 upon 3, 2 into b plus c. Therefore 2 by 3 into 1 by 2 equals to b plus c. Now b plus c equals to 1 upon 3. Now putting the c value, what is the c value? C value 2 by 3. So putting C value 2 by 3 here equals to 1 by 3. So B equals to 1 by 3 minus 2 by 3 equals to minus 1 by 3. Therefore, B value equals to minus 1 upon 3. Therefore, 1 upon 1 plus x cube equals to 1 upon 3 divided by 1 plus x plus minus 1 upon 3x plus 2 by 3 upon 1 minus x plus x square. Next step, 1 upon 3 into 1 plus x plus minus x plus 2 upon 3 1 minus x plus x square equals to 1 upon 3 1 plus x, writing positive term first, therefore 2 minus x upon 3 1 minus x plus x square. So 1 upon 1 plus x cube equals to 1 upon 3 into 1 plus x plus 2 minus x upon 3 1 minus x plus x square. And these are required partial fractions. Required partial fractions.